Nope. Y to the fourth x squared, that one is. How about this? Nope, no, no, and no. So those two can combine. 3 minus 2 makes 1. So will we write 1y to the fourth x squared? No, we don't need the 1. 1 times anything is itself. We're always trying to simplify things in their simplest state, so it's just y to the fourth x squared. We can cancel those out. We've got 2y to the third x and negative 2y to the third x. So a y to the third x and a y to the third x. A positive 2 and a negative 2 do what? What do they do, Diamond Dave?
They get each other gone. They cancel
each other gone.
There's my fine English for you.
That sounds good. Where were you born?
I was born in Missouri.
No, you were born in a barn, bro.
Absolutely.
Okay, so we've got negative 3y and positive 4y, and that again makes 1y, which we'll just call plus y. Those will be gone. And then you'll notice I have a negative 7 here, okay? And we could, maybe quadruple underline that. And we have a negative 5 over here. Notice we had a 2x. And so there are no other x terms up here, so we could write the plus 2x. Then the negative 7 and the negative 5 would combine to make negative 12. We can re-examine this, see if we can combine anything else. We can't, so we are done, okay?
All right, I've stepped out from behind the camera, come to talk to you from this end. So,
I'm behind the camera.
So here, again, in 4.5 and 4.6, we talked about the multiplication of polynomials, or multi-polys. And so with this, we're just doing the same thing, but now we have multiple variables here. Here we have m to the third n plus 8 times m to the third n minus 6. And so with this, we're just going to take everything in the first parenthesis times everything in the second parenthesis. And so we could do this a few different ways. One way we could do this is we could say that this is m to the third n times m to the third n minus 6 plus 8 times m to the third n minus 6. And now we can just distribute the parentheses. We can say m to the third n times m to the third n. Now here we have the product rule in place. And so we have m to the third times m to the third when we're multiplying the exponents, we add them together. So that's m to the third plus 3. And so that becomes m to the 6th. My marker's going out. Okay, m to the 6th. And then we have n. We have n to the first plus n to the first. So n to the 1 plus 1. And it becomes n to the second. Now we can combine these together and we have m to the 6th n to the second. All right, that's taken care of this times this. Now we need to take this times this. Now this is going to be easier because all we're doing is we're affecting the coefficient here. And so we have m to the third n times negative 6. That's going to give us, now I'm going to draw a line between what I'm working on my answer. That's m to the 6th, n to the second. And then we say minus 6m to the third n. Now, we've completed this first part of the by times the by. I believe there's an NSYNC or Backstreet song or something that has to do with by times by. All right, moving on. So we say, okay, now we've got 8 to here and to here. This one's going to be a little bit easier because we're not taking exponents times exponents in this case. We can say 8 plus 8 m to the third n, and that takes care of that times that. Now we take 8 times negative 6. And 8 times negative 6, pull out your calculators, work on it a bit. You find that 8 times negative 6 is negative 48. So we say negative 48. Now we need to check and see if we have any like terms to combine. We've always got to check for those. We always got to keep a lookout. Is there like terms? Well, there are no m6, or there's only one m6 into the second. None others are in there. So we go ahead and put our answer down. M, 6n to the second. And we can go ahead and cross that one out. Now, m to the third n, there are two of these, so we're going to go ahead and circle those. Negative 6 plus 8, it's going to be plus 2 m to the third n. And we go ahead and get rid of those because they're ugly and we want them gone. Now we say, okay, the last one, well, obviously there's no others right there, so we say negative 48. Now, as Brother Rich talked about, we always double check, see, well, m to the sixth, n to the second, 2m to the third n, negative 48. There are no more like terms, and we are completed, we are finished, and we can say goodbye to this problem.
Diamond Dave, hit it.
All right, so here we have some problems that are very similar to ones you will see on the exam. We want to help prepare you for it, get you ready, get you pumped. So we've got two problems here that are dealing with multiplying. And we want you to try to work through these, try to see if you can solve them. We've got number 58 and number 79 from the homework if you want to double check them.
So right now, why don't you guys hit pause and do these two and rejoin us in a minute. So hit pause right now, try them, and come back to us. Go for it. Okay, Diamond Dave, slapping me the pen. All right, I'm gonna do the first one. Diamond Dave's gonna do the second one. So we have 3a plus 2b squared here, and we talked about this in class. We cannot simply square everything in here. We cannot say this is 9a squared plus 4b squared. Okay, we can't take the square to everything in there because we talked about how when we multiply polynomials, we can't take the shortcuts like we do in the power rule when we have a monomial. Okay, so we have to say this is 3a plus 2b times 3a plus 2b. And so we, again, I like what Brother Jesus did.
Not to be.
There you go. 3a is going to be multiplied times 3a plus 2b. Okay, this times this. Plus 2b times 3a plus 2b. Again, we'll end up with 3a times 3a plus 3a times 2b plus 2b times 3a plus 2b times 2b. Now, Brother Jameson and I do this slightly different. And I like what he did with his class on the last example. But here we have the mono times the mono plus the mono times the mono. And we have 4 mono times monos. Remember, numbers go with numbers. We have 3 times 3 and A and A. Here we have 3 and 2 and A and B. Here we have 2 times 3. And we do BA or AB. Well, we're going to do AB because this one is that way. So we don't look like we have two different terms there. We've talked about that. And this will be 2 and B and B. And we talked about how we rearrange these according to the commutative law, because since everything's being multiplied in this mono times mono, we can do numbers with numbers. 3 times 3 is 9. A times A is A squared. 3 times 2 is 6. And that is just AB. 2 times 3 is also 6. And we have an AB. And here 2 times 2 is 4. And B times B is B squared. These two combine, and we have 9a squared. These are like terms. 6 and 6 make 12 ABs, and we have plus 4b squared. Who got that right? Say woo. Woo! Yeah, I missed doing that with you. Okay, I'm going to erase this one and let Diamond Dave do this problem here with you, okay? Go for it.
All right.
Oh, sorry. You guys should call him Brother Jameson, but I'm going to call him Diamond Dave.
It's all good. All right. So here we have a trinomial times a trinomial. We're multiplying. So we can do it the same way that Brother Rich did, or we can do it the way I did. Let's go ahead and actually try doing it the way that he did it there. So everything in this parenthesis is multiplied times everything in this parenthesis. We need to make sure nobody is left behind, no polynomial left behind. That's our motto here. So we say, well, that's the same as saying x squared, my first term, times everything in the next parenthesis, 3x squared plus 5y minus 3 Now this could also be expressed by saying, well, you have x squared times 3x squared plus x squared times 5y plus x squared minus or times negative 3. Now, one thing that this can become quite tedious for some of you, and I've seen students who hate this, but this is one thing that this is really good at doing. It's really good at making sure nothing is left behind, nothing is confused, nothing's mixed up. So while it takes up more board space and you may not like it, it actually will end up helping save you when you're in the exam to make sure nothing's left behind. All the time I get students who leave one of them off. They forget to multiply one of the terms and they end up having problems. This helps fix that. It helps be a safety net for you. So, and then we'll go on with the rest, but I just want to first do this one term times all the other terms. We'll get that answer and then we'll go on to the next term times all the rest. Just hopefully that confuses you less. So we have x squared times 3x squared. Well, the numbers with numbers, 1 times 3 is 3. X squared times x squared, we end up getting x to the 4th. We end up having x to the 2 times x to the 2, which is x2 plus 2. And then we say, okay, that takes care of those. X squared times 5y. Now here we don't have any variables that are the same here. But we say plus 5x squared y. The common way that you will see it in the exam most often is they'll put it in alphabetical order like this. And so x squared times 5y. Then we say, okay, plus x squared times negative 3. Well, that's not going to even be a plus, really, because it's a positive times a negative. So we say negative 3x squared. Now, we don't have any like terms here. We will probably have some more like terms once we do the rest of it. But here is just the first term that we had here times everything in that parenthesis. All right, let's move on. So I've taken a little bit more time with this first part. I'm going to move a little bit faster with these next ones. So I say, all right, I took care of this term here times everything in the parentheses. Now I'm going to use the second one. So I'm going to say minus 4y times 3x squared plus 5y minus 3. There I've got the second term in the trinomial times everything else. And I'm going to go ahead and put the third one down, which is plus 2 times 3x squared plus 5y minus 3. And we can go ahead and do what we've done before. We say, now I'm going to go ahead and just draw a line through this so we don't confuse it. We've already solved it. We've got it down here. We'll say negative 4y times 3x squared plus, well, we don't even need the plus because we've got a negative. I need to remember that. That's on me. We say negative 4y times 5y and negative 4y times negative 3. When we go ahead and go through this, we say negative 4y times 3x squared. That becomes negative 4 times 3. We're doing numbers with numbers. Negative 4 times 3 is negative 12. Y times x squared y. That's taking care of our first term, our first mono times mono there. Then we have negative 4y times 5y. Numbers with numbers. Negative 4 times 5 becomes negative 20. Y times y is y squared. We've taken care of that. Negative 4y times negative 3. Negative times negative becomes a positive. So we have negative 4 times negative 3 becomes positive 12. And y. Now, we've taken care of that term. Let's now go to the last term here. 2, our last term in the mono, times everything else. Then we'll go in and just really quickly clean up, find any common terms, like terms there. So we now say 2 times 3x squared. Now, I'm running out of board space. So I'm going to go ahead and bring it down just below here. 2 times 3x squared plus 2 times 5y plus 2 times negative 3. Mono times mono, mono times mono, mono times mono. 2 times 3x squared plus 6x squared. 2 times 5y, we get plus 10y. 2 times negative 3, we get negative 6. Now we need to go through really quickly and clean up all these like terms. Get them, as I've talked about, it's tidying your room, it's straightening things, it's making things neat and orderly. Mathematicians are order freaks. They like seeing things clean. So, 3x to the 4th. There are no other x to the 4th. I can do this really quickly just by seeing if I see any 4s right at the top. And I don't. So I say, okay, that's going to come down to the end answer. 3x to the 4th. And I get rid of it. Now, this one's a little harder. We've got a lot of 2 exponents. So we say 5x to the 2y. Not x to the 2y. Oh, x to the 2y. So I'm going to circle this. Circle this. They're both x to the 2y. Not x to the 2y, not x to the 2y, not x to the 2. It's got x to the 2, but no y. Not x to the 2y, and so on. So, 5 minus 12, negative, that is an ugly 7. We're going to rewrite that. Negative 7x to the 2y. And I get rid of both of those. Now I say, okay, 3x to the second, well, negative 3x to the second. Are there any other x to the second? Not x to the second, not x to the second. Oop, x to the second. So, I'm going to do a wavy line underneath that one, and underneath that one. No more x to the 2's. So, negative 3 plus 6, that's plus 3x to the second. And I get rid of them. Negative 20y squared. I'm going to put a box around this. Oh, got a y, but not y to the squared, not y to the squared. What do you know? That's the only y to the squared. So, negative 20y squared. I'm going to do some double underlines under y's. I've got 12y plus 10y. That gives me plus 22y. And I get rid of these. And then the negative 6 just comes along at the caboose, finishing it up. We look at it, there are no repeats. And we have completed the problem.
Awesome. Well, hopefully you got that right. That was a challenging problem. One of the things that we want to emphasize, the 2 examples that we just put on the board, they mimic 2 problems that you're going to see on the Chapter 4 test. This is one of the more involved problems. A trinomial times a trinomial is all about being thorough and being organized. Good luck, and we'll see you in section 4.8.